Thanks everyone for joining us tonight. So my name is Yondon and I'm one of the co-founders of Livepeer. So thanks Shannon for the great introduction to all the work that we've been doing here at Livepeer. And with my presentation, I'm going to talk a little bit about this notion of decentralized video compute and applications. So Shannon alluded to this new feature that we launched recently called IPFS CID video streaming playback. I'm going to talk a little bit more about that feature, how it works, and also taking a step back and talking about our vision for how decentralized video compute can work alongside decentralized storage. So just to do a brief overview of the agenda, I'm going to start by talking about this concept of video compute on decentralized storage. Then I'll talk a little bit about that feature that Shannon showed around IPFS CID video streaming playback. And then lastly, I'll take a step back and talk about this pipeline, this video compute pipeline that we think that Livepeer can enable for the broader decentralized web. So, video compute on decentralized storage. First, I want to talk about this notion of CIDs, which is a term that has come up again and again. And CIDs are an interesting construct that emerged from the IPFS ecosystem, where I think it's best described some of the value prop of this concept in this screenshot that I took from the nft.storage blog post. I won't go through all of the text, but the basic idea here is that the really nice property about CIDs is that because it's calculated based on the hash of the data, the actual identifier that you use to reference the data is always verifiably linked with the data itself. So given an ID, you know that you're getting what you expect given the ID. So at Livepeer, we care very much about videos. So with CIDs, we care about video CIDs. So the only difference here is that when you calculate a CID, the underlying data that you're calculating over might be a video file. But what's interesting about videos specifically that I think distinguishes videos from all other media formats and other types of data that you might calculate CIDs over, that you might store in decentralized storage, is that videos are actually really complicated in terms of formats and renditions. You have different qualities, you have different edits. You can have a single video that a creator created, and then online when it proliferates, you have different versions of that same video, and they're all slightly different, but visually speaking, they're the same. So, how do we deal with that situation? We just talked about how video CIDs are this really useful concept. Well, a CID is great as a verifiable link, but on its own, if you just have a single file and then you calculate the CID over it, how do you handle all these different renditions that are going to merge, right? You have a single ID for a single video file, but now you have all these renditions. How do you capture that? On the flip side, if we just stay in the Web 2 world, that's a solved problem. We have a YouTube URL that can serve many possible renditions, but I think a lot of people know the downsides of a YouTube URL, it can break, right? Because the URL is actually a reference to a location and not the data itself. So what can we do about this? Well, the ideas that we've been working on at Livepeer recently is thinking of CIDs as this shared verifiable data layer that you can then layer on video compute on top of. So rather than trying to solve all of this with a single CID that represents everything, we solve this by having CIDs serve as the original reference to content that is shared and it's verifiable, and it's the root of all computation that's going to happen afterwards. Then from there, as I was just talking about how there's many different renditions, qualities, filtered versions, those are all downstream of this root CID, where you can have the root CID reference a piece of content, and then you can have this pipeline. And this pipeline takes in that CID, takes in that source content, and now from a single piece of source video, you can generate these different varieties for different use cases and different experiences. And all of this can be performed by applying compute transformations on top of CIDs themselves. So we like to think of CIDs as base ingredients for enhanced renditions. So you can have one or many CIDs come in, and then those are the ingredients that are used to create more complex and interesting video experiences, even if the original base CIDs were just references to single video files. So that brings me to the feature that Shannon mentioned, IPFS CID video streaming playback. So in order to set the stage here, as Shannon mentioned, transcoding is a really important part of the internet, and I would go as far to say as it's the plumbing of video streaming. And the reason that I say that is because a lot of people will say that they want to build the next YouTube or a better version of YouTube. And that's a great ambition and that's a great goal. However, a lot of times the thinking kind of goes towards ensuring fast delivery of the content, which is definitely very important. But if you want to do that, you're going to need a little bit more. You're going to need things like transcoding. You're going to need things like transmuxing. There's a couple others that I can get into if people are interested in separately, but transcoding is this process of basically taking an input video and then compressing it into all these different qualities so that you could be on any internet connection in the world, any device type, and you still get a smooth experience because the video player that you use is intelligent enough to constantly switch between those different versions. So that's the end goal that we want. That is what it takes to build a YouTube-like video experience. How do we get there? So in the decentralized web, when we're working with these CIDs or when we're working with this shared verifiable data layer, how would this workflow work? And what we've built is this IPFS CID playback feature, and we have a Livepeer.js docs page that's available for demo, and if folks are interested, can share links with that separately. But very high level, what's happening is that you are able to drop in a CID or an IPFS URL. It could be IPFS://CID. It could be a gateway URL. It doesn't really matter. As long as the content is identified by a CID, you can plug that in, and then with a couple lines of JavaScript code, you're able to take that CID, send it into this video compute pipeline that's processed by the network, and then out on the other end is high-quality transcoded playback. So this is roughly the amount of code that takes today in order to enable this feature. So on the left, you have a couple lines of code in order to set up some basic React boilerplate in your front-end application. And on the right, you have some custom code to basically take that CID and then pass it into this custom-built JavaScript player component that we built. And we think we can actually reduce the amount of lines of code even further, but it's already not that much, so that should give you an idea of how easy it is to basically take a given CID for a video file and then also transform it into this better playback experience. And these are two screenshots of a before and after, where on the left, hopefully you can see, is a video that's referenced by a CID that's being played back from an IPFS gateway. And then pretty soon after you start playback, you hit this loading circle, which isn't great. So you're going to see this stuttered playback experience, which for a lot of viewers, after they encounter it one or two times, they're out. On the other hand, when we use the CID video streaming feature, we're able to drop in this IPFS URL with the same exact CID. So from a developer standpoint, you want to use CIDs, you have these existing assets that are stored in IPFS, no problem. You just take that CID, you drop it into this JavaScript component, and it'll just work. And on the right, you're going to be able to get much smoother playback. You could have a worse internet connection, a better internet connection. The player's smart enough to switch between the two. And that's because there are different transcoded versions. Oh, bell's going off. Maybe I should speed up. So I'll take a step back, and that was the IPFS CID video streaming feature. And we think that is a step towards a vision of what we describe as the decentralized storage video compute pipeline. So we talked about transcoding, we talked about transmuxing, we talked about a good playback experience. That's great, that's what's required, that's table stakes for something like YouTube. But are there other types of video compute that could be interesting as well? So a couple that I have screenshotted here should illustrate some of the things that we can start enabling once we have this pipeline that's rooted in these original video files. You could do things like audio transcription, using some of the latest neural network technology, where you can take a given audio stream, parse the actual audio text, and then insert it as metadata into a video track, and now all of a sudden you have closed captioning, and that was fully automated. You can do things like video restoration, where I might have recorded a video 10 years ago when the hardware was not as good, so there's no way that I can do 4K, or no way that I can do 8K or whatever that we're up to now. But you can use techniques like ESRGAN, which is a super resolution technique that can take an input video and upscale it and then force it into a higher resolution and basically fill in the details for you. That would be pretty cool, right? We can create high-res versions of things that we recorded on our potato iPhone 4 from like 10 years ago. So that's pretty cool. And on the example on the left is just something that you can do where you can take an input video and upscale it, and you can see that on the right, it's much higher quality than the one on the left. A lot of people here might be familiar with the generative AI craze, and one of the cool things that you could do with generative AI now with stuff like open source stable diffusion models is you can actually create videos. The videos are still a little bit primitive, but given the rate of progress, you can imagine that we're going to move pretty quickly here. So on the right is actually a stable diffusion video that I created, and the way that I created this was actually using open source stable diffusion tools where you can use 2 text prompts, generate an input image and an output image, and then what it does is it interpolates and generates all the frames in between, so you end up with sort of a really fast slideshow of visual transformations from the original image to the output image. And all of this is enabled with not only AI technology and generative AI, but also standard video tools. You can see on the screenshot on the bottom, this is the equivalent command in a tool called FFmpeg in order to actually generate this video, where you can generate the images, but you still need to do things like concatenate all the frames together, make it smooth playback, and then encode it into a video stream that can then be sent out. But those are all things that can be glued together, and those are all things that could be a part of this video compute pipeline. So this is a brief diagram of what we imagine examples of this pipeline looks like. I won't go through all of the flows here, but you can see some examples here where video input comes in, you can decode it, you can scale it into bigger or smaller versions, you could transcribe the audio, encode it, send it out. On the bottom, you can take text inputs, you can do text-to-image models, you can concatenate frames together, encode it, send it out. At the end of the day, these are all video outputs. These are all new ways of creating videos, whether you start with a video or you start with some other form of media. And through all of this, we imagine this to be rooted in this shared verifiable data layer. And that is enabled by decentralized storage, where you can have this open data layer that's available and accessible to anyone. And people are able to build new and interesting experiences on it because the open data is accessible to all via these CIDs. It's verifiable. But now you can construct these compute pipelines on top. So not only do you have the data accessible, you can do these really interesting things with it. You can transform it. You can create these new experiences using the pipelines that I talked about. And lastly, in an ideal world, you would have a situation where you have verified inputs in and verified output out. And what I mean by that is that if the root is the CID, I want to be able to say that this output video can be linked back to that original CID. So in the ideal world, we can say that we created this amazing new video using this pipeline, and it's always rooted back to this CID, and that's something that a developer or an application is able to use as metadata. And that is really important in this world where you have all these formats and renditions of the same original video. And that's something that we've been thinking about and working on as well. And if anyone's interested in that topic, I'll be talking about it more at the Compute Over Data Summit tomorrow, or happy to talk about it later after this as well. So ultimately, we think that this is an integral part of this vision of the world's open video infrastructure. And why does that matter? We think that the world's open video infrastructure is the big enabler that results in innovative new media formats, so new ways that we can consume media and video online, and video experiences, where the way that we experience our videos today is limited by the amount of applications that can exist that experiment with all these experiences. But what if we lived in a world where there can be much more exponential growth in the amount of people experimenting with video applications? We think that that means there's just going to be way better experiences going forward, not only for the Web3 crowd, but for everyone on the internet. So that's it for my presentation today. Thank you so much for taking the time. And if anyone's interested in chatting more, happy to chat later. I might take questions now or later, but yeah, okay. Then I'll pass it off to Juan for his talk.